Hello, Algebra 2 students. Today we're going to be taking a look at equations of parabolas. Please copy down the title as well as the objective. And our objective is to learn the specifics of the equations of parabolas. Now, this is not a new story, not a new discussion. We have spent a considerable amount of time this year talking about parabolas and their equations. Okay, so there's a lot of math that goes along with the quadratic and the parabolas and stuff like that. We already know all that, but this is more in keeping with the discussions that we've been having on conic sections, how to read the equation in order to understand what to expect from the graph. So a little bit of new information, but not nearly the depth of what we had been talking about when we did equations of parabolas back around the turn of the semester. Anyway, our general equation for a parabola, okay, our unit conic section might look something like this guy, y equals x squared. Now, again, we've already seen the quadratic from the perspective of a parent function. Now, the quadratic that we're looking at now looks slightly different. Okay, here's how it's going to look from the perspective of conic sections. Okay, y minus k on one side of the equal sign. On the other side, we have x minus h quantity squared. Now, of course, we have h, k is our vertex. Now, you may be thinking, hey, wait a minute. When we did quadratics and parabolas back in December and January, we learned that k was over on the other side of the equal sign with the x minus h. And true enough, you are correct, it was. And if you remember, when it was over on the right side of the equation, it was plus k. Okay, so that actually makes sense, okay, that it was x minus h quantity squared plus k, and it's minus k over on the left side if we simply subtract it to the other side. So that makes sense. So if you're curious or questioning how come is it being represented on the left side of the problem with the y rather than the right side of the problem with the x minus h, well, it actually has to do with the sign of y. You're going to find that it is actually a little bit more accurate if k can exist on the side of the problem where y exists. Okay. Anyway, moving on. The negative signs are built into the formula as always. This also keeps kind of a uniform discussion of how we've been doing the k and the h values all the way through the conic sections, x minus h and y minus k. So that's the same as the other two we've discussed thus far. Okay, and also please note that either variable can be the second dimensional variable, which is, so it's not to say that y is always to the first power and x is always to the second power. It could very much be the other way around. So it could have been x minus h to the first power equals y minus k to the second power. Okay, and a little bit of information, and we've kind of touched on this earlier this year. Okay, so this is somewhat review, but the parabola will open in the direction, including the sign, of the first dimensional variable. Okay, that's an important piece of information as far as understanding the equation of the parabola and deciding what to expect from its graph. Okay, so let's take a look at these equations. Okay, let's start off with this one. Negative y equals x plus 2 quantity squared. Okay, well, there's really only two pieces of expected information that we can pull from the formula. The rest of it would be getting the specifics of the equation, right? Okay, but we can read the vertex and the direction that the parabola will open from the equation if the equation is formatted correctly, and we'll get more to that here in just a second. Hopefully by this point you should be able to read the vertex pretty easily out of the formula. Okay, and our vertex in this case is at -2, 0. Okay. Now, as far as the direction that it opens, remember that the parabola is going to follow the first dimensional variable, including the first dimensional variable sine. So in this case, it is y that is in the first dimension. That means our parabola is either going to be opening upward or downward, depending on the sign of y, and our sign is negative. So that means our parabola is going to be opening downward. Okay, so that's kind of the extent of what we can read from the equation. Let's look at another one. Let's say x minus 4 equals y plus 2 quantity squared. Same pair of questions. We'd like to know where to begin, and then we'd like to know where to draw from there. Okay, well, hopefully your vertex is not a challenge. Okay, we have an x value of positive 4, a y value of negative 2. So we've got a vertex at 4, negative 2. Okay, and the direction that the parabola will open, it's going to follow the first dimensional variable. In this case, that is the x, so it's either opening leftward or rightward, depending on the sign. The sign of x is positive. Okay, so that's going to follow the positive x values, and that's to the right. Okay. Now, once again, these problems, kind of similar to our discussions on the circle, these problems can be a little bit jumbled up, and we can be expected to complete the square in order to read the information. This time we're looking at an equation that says 0 equals negative y squared plus 6y minus x. Clearly, all the information is tangled up with itself. We're going to have to sort it out before we can read anything about the vertex or the open direction or anything like that. Okay, so the first thing we have to decide is which variable is going to be the first dimensional variable, because that is what we base so much of the information about the parabola on. Okay. Now, clearly in the equation, we have two first dimensional variables. You have y to the first and you have x to the first. But we also have y squared. So the y's order is actually 2. Its highest power is a 2. Okay, so it's not going to be the y that is the first dimensional variable. It's going to be the x. So the first thing I would do is I would isolate the information about x. Okay, so that would mean adding x to both sides of the equation, which would give us this. X equals negative y squared plus 6y. Now, going to need to complete the square on the y values over there. We cannot read the vertex when it's in this format where we have y's in more than one dimension. Okay, so we're going to complete the square, but one of the things that you have to pay attention to with completing the square, and we did not stress this too terribly much, is that the coefficient in front of that second dimensional variable there absolutely, positively must be a positive 1. Okay, so that's not allowed to be a negative 1 or any other value. Okay, it couldn't be a positive 2 or a negative 19 or anything. Okay, that value, that coefficient in front of y squared needs to be a 1. So we're going to get rid of that negative by dividing the entire problem by the value we're trying to get rid of, which is a negative 1. So that's going to flip all of the signs. So positive x becomes negative x, negative y squared becomes positive y squared, and positive 6y becomes negative 6y. Okay, now we are free to complete the square for the y values. Okay, so looking at the y values, we pay attention to its first dimensional coefficient, which is the negative 6. We're going to take that negative 6, we're going to half it, and we are going to square it. Okay, so half of negative 6 is negative 3, and negative 3 squared is positive 9. So both sides of this problem are going to get a positive 9 added into it. Okay, that's the completing the square method that did that. All right, now we should be free to simplify this trinomial on the right side into a binomial squared. So remember that the factorization of that trinomial is we take the square root of the lead term, square root of the trail term, and then we keep the sign of the first dimensional term. So we're going to have square root of y squared right there. That's going to be a y. We're going to keep this sign, so it's going to be y minus, and square root of the trail term is going to be a 3. So our factorization is going to be y minus 3 quantity squared. All right. Now, there's only one more thing to tend to before we deal with the questions at hand, which would be the vertex and the open direction. Notice the negative in front of the x. Now, we've already decided or discussed that it is possible for us to have negative first dimensional variables, and that's fine. Okay, but that negative needs to affect the vertex as well. We've seen this all along as we've been doing our parent functions. Whenever the variable that we are focused on has a negative sign in front of it, it also influences how we read the vertex or the center that is attached to it. So the easiest thing to do is I'm actually going to take that negative and I'm going to factor it out of this entire binomial. So I'm going to take a negative out of x and a negative out of positive 9, and that would give me this step, the negative of x minus 9. Now, if that confused you on how we were able to do that, we'll consider the reverse situation. What if we were to redistribute this negative back into the positive x and the negative 9? Would you get your previous step back? Yes, absolutely you would. Okay, so it seems a little strange to do that, but it absolutely does check out. Now, in this format, we can read things like vertex and accurately answer the opening direction of the parabola. Okay, now the vertex, just reading straight out of the equation like we have been for the last two conic sections as well, we're going to have a positive 9 for our h, and we're going to have a positive 3 for our k. Our vertex is at 9, 3. Now the opening direction, same as before. Pay attention to the first dimensional variable, which is the x, and read its sign. Negative x. Our parabola is going to follow the negative x-axis. That is off to the left. Okay, now graphing it is really not much more difficult at all, because we're not specifically worried about getting the parabola with the proper opening width and stuff like that. We're just trying to get it into the graph. Okay, so let's take a look here. We have an equation, negative of x minus 4 equals y plus 3 quantity squared. Now the formula already fits the standard notation, standard structure of the parabola, so we don't have to do any crazy completing the square stuff like we did before. We can simply answer the questions: where is the vertex and which direction does the parabola open? Okay, well, the vertex is, reading straight from the equation, our vertex is at 4, negative 3. Okay, once you have your ordered pair, you can plot your point. Now we just need to address the direction that the parabola is going to open. And the first dimensional variable is x, and it carries a negative sign. So once again, our parabola is opening to the left. And as I said, we're not really worried about the width of the parabolas. We know that there's a lot of things that can change the width of the parabola. Okay, just try to get the basic width correct. Okay, from our discussions of parabolas, you should know as you move 1 unit to the side of the vertex, it also moves 1 unit forward in the opening of the parabola. As you move 2 units to the side of the vertex, that moves basically 4 units in the opening of the parabola. So you should be able to get a basic opening width without it being way too skinny or way too wide or anything like that. Okay, so that is the conic section version of how to graph parabolas. Okay, also keep in mind with parabolas, there are the thing has an axis of symmetry passing, in this case, a horizontal axis of symmetry passing right through the vertex of the parabola. Okay, an axis of symmetry is a common question for test writers to ask about when it comes down to parabolas. So keep in mind, and that's something that we've talked about before, so you may need to go back and review if that is a little bit of a mystery to you. Anyway, I appreciate you finding time to get your notes taken care of. I'll see you in class.